The primary school in Hohen Neuendorf, north of Berlin, is the first new-built plus-energy school building in Germany. Based on the ambition of the city of Hohen Neuendorf to become a green city and the need to minimize the long-term running costs, the main objective for the design was to develop a sustainable concept that provides good learning and teaching conditions with low operational costs for the commune. The primary school has a gross floor area of 7,400 square meters and is designed for 540 pupils. A central school avenue connects the two entrances with all functions of the building. Administration and teachers' rooms are located near the main entrance. The classrooms are grouped in 3 wings and are oriented to the south. Specialist rooms for arts, music, computing, nature sciences, a small library and a cafeteria are oriented to the east. The sports hall offers a floor area of 1,200 square meters. The integrated design approach conceives all technical, energy-based and functional requirements as an integral part of the architecture and permits a lean technical concept with a simple, easily controllable and low-maintenance engineering system for reaching a high-comfort indoor climate. The design provides excellent learning conditions regarding spatial quality, air quality, thermal and visual comfort. The main technical features of the energy concept are the highly insulated passive house standard, a newly developed hybrid ventilation concept, an optimized daylighting concept, the use of renewable energy sources, and the integration of innovative building components. In cooperation with the teaching team, a room concept has been developed that enables different kinds of teaching situations. The so-called home area consists of a multifunctional room in combination with a smaller teaching room, an extended circulation space, a wardrobe and a sanitary unit for each class. The technical concept for ventilation and lighting is based on this room concept. By grouping the classroom and sanitary unit to a home area, a combination of natural and controlled ventilation can be realized. The advantages of both ventilation types are combined to create a good balance of thermal comfort, air quality, user acceptance and energy efficiency. The ventilations of the classrooms is primarily achieved by a rapid natural ventilation during the breaks using motor-controlled full-height vent windows. With only this type of ventilation, CO2 levels will increase quickly during the lessons. Thus it is combined with a small mechanical ventilation for dampening these magnitudes. The supply airflow for these classrooms correlates to the amount of the exhaust airflow needed for the sanitary units. A good thermal comfort in summer is achieved by means of passive night cooling using the motor-controlled vent windows cooling down the large areas of thermal storage mass. One research objective in the project is the trade-off between thermal storage in the concrete ceilings on one side and a good room acoustic quality on the other side. To achieve best possible results for both requirements, the concrete ceilings are left uncovered for good thermal contact, and the biggest part of all available wall surfaces is covered by highly efficient broadband acoustic absorbers. Thus, a high room acoustic quality, according to the ambitious DIN education standard, can be achieved without affecting the passive cooling functions of the ceilings. The south-oriented facades of the classrooms have been developed in detail to provide efficient solar shading, natural lighting and passive solar energy gains. Fixed exterior blinds protect the windows against incident solar radiation in summer, Vertical fabric blinds enable efficient solar control due to user requirements. Almost every space is designed to have a very high daylight autonomy. The circulation spaces are well oriented to the daylight to provide attractive room quality. The use of bright colors supports the attractive appearance. The daylight performance of the sports hall was calculated and optimized. The deep spaces of the classrooms receive natural light from two opposite sides. The small rooms get natural light from only one side. The main structure of the building comprises of concrete walls, concrete ceilings, and a concrete roof for the school building and a timber roof construction for the sports hall. The building has a very good thermal insulation level that achieves the passive house standard. All the applied measures lead to a very low energy demand for the building. The calculated annual primary energy demand for heating, cooling and lighting is 23 kilowatt-hours per square meter and year. A partial compensation of this need is realized by a micro CHP, which is used throughout the year to cover basic loads. For the compensation of the remaining primary energy demand, a building integrated photovoltaic solar power plant of 55 kilowatt is used. The annual primary energy production by the CHP and the integrated PV power plant is 24 kilowatt-hours per square meters and year. The design phase of the project was accompanied by a life cycle analysis. The calculated operation costs for the school building are 70% less than the operation costs of a building of the same size and shape that refers to the German standards. The calculated life cycle costs are 25% less. The building was finished in August 2011 and a 2-year intensive and 5-year long-term monitoring program started to evaluate the building's performance and acceptance.